All right, now we're ready to learn how to do circuit analysis. This is what we've been shooting for as we've learned our fundamental laws. And the fundamental laws are Ohm's law and Kirchhoff's laws, which we learned with Kirchhoff's current law and Kirchhoff's voltage law. This says that the sum of all the currents going into a node adds up to zero. And the voltage law says the sum of the voltages going around a loop adds up to zero. And the other thing we learned was the sign convention. So we had a passive sign convention, which was if I label a voltage like that, then I label the current flowing into the positive end. The positive end and the current go together. So these are the tools that we have for analyzing a circuit. And I've drawn a circuit here. So what we see is we have a voltage source. We'll call that Vs, and we'll give it a value of 15 volts. We have a resistor, R1, that has a value, we'll give that a value of 4K ohms. And another resistor, R2, is sitting right here. And we'll give it a value of 2K ohms, 2,000 ohms. And finally, there's a current source sitting over here. And it has a value of 3 milliamps flowing downwards. So the point of circuit analysis means what we want to do is we want to find all the currents and all the voltages in this circuit using our fundamental laws. So let's identify the nodes in the circuit. We'll give them letter names. We'll call this node A, and that's the junction between R1 and Vs. We'll give this one a name. This is a node that's distributed. All three of these components join right about here. We'll call that node B, and that's one of the nodes. And down at the bottom here, there's the third node, which is this distributed node here. It connects the voltage source, the resistor, and the current source, and this is all, we'll call that node C. Now we can also label some voltages on here. We'll label the voltages, we'll do that in orange. Okay, we'll call this V1, and we'll give it a plus sign here and a minus sign here, and that's the voltage across R1. We'll give R2 a name. We'll get the voltage here, we'll call this plus minus V2. That's the voltage across R2. It's also the voltage across the current source. B, it's the voltage between node B and node C. And now let's label the currents. Let's label the currents in this circuit. We have a current coming through R1. We'll call that I1. There's another current going through R2, and we'll call that I2. There's a current going here through IS, and we actually already know that. We'll just call that IS. And that's all the currents. That's all the unknown currents in our circuit. If we stare at this, we're not going to be able to tell on just inspecting this what's going on. We have to come up with some solution technique. And we're going to solve this by what's called application of the fundamental laws. And here's our laws over here. And the whole technique is based on solving simultaneous equations. That's the skill of circuit analysis. Circuit analysis means setting up and solving simultaneous equations. So let's write down some things we know about the circuit. And first thing we're going to apply is we'll apply Ohm's law to the two resistors. So we can say V1 equals I1 times R1. And we can say that V2 equals I2 times R2. All right, that's not a bad start. We have two equations. How many unknowns do we have? I2 and V2 are unknown. I1 and R1 are unknowns. So we have 4 unknowns and we have 2 equations. So we're halfway there. And now we need to come up with some more equations. And I'm just going to stare at the circuit. And what I'm going to do is I'm going to apply KVL around this loop here. That's going to be my KVL loop. And after we get that equation, what we're going to do is we're going to write KCL. We're going to write the current law at node B. That's the 2 equations we're going to develop here. So let's do KVL. Let's start in this node at this corner of the circuit and go around clockwise around. And what we see first is a voltage rise plus Vs. Next I see a voltage drop, so it's minus V1 going around this way, minus V1. I'm at this point. Now I'm going to go through R2 and I see a voltage drop of V2, minus V2 equals 0. That's Kirchhoff's voltage law around this loop. 1 rise, 2 drops, 1 rise, 2 drops. Now we're going to move up here and do Kirchhoff's current law at this node right here. So let me draw a few more arrows. This is I1. It comes right through that resistor. And this is IS. So Kirchhoff's current law, let's count the currents going into node B. Current going into node B is I1. Currents going out, we'll set that equal to the sum of the currents going out of node B. So that's equal to I2 plus IS. So look, now I have my 4 equations. Here's my 4 simultaneous equations. And this is what we have to solve. So let me move the screen up and we'll start doing that. Let's do a double check. We had 4 unknowns, V1, I1, V2, I2. Here's V1 and V2, and here's I1 and I2, and I have 4 equations. So we ought to be able to do this.